Hey everyone, my name is Kenny Coleman, and I'm a Technical Marketing Manager for VMware Tanzu Kubernetes Grid. With VMware Tanzu Kubernetes Grid, all of the open source components for natively building enterprise-ready Kubernetes clusters are packaged together for a tightly integrated offering. TKG provides easier installation, automated cluster operation, high availability, and open source alignment to the upstream Kubernetes community. In this demonstration, we'll be looking at the VMware Tanzu Kubernetes Grid CLI and all of the aspects of cluster lifecycle management. This demonstration will be using TKG on vSphere 6.7 Update 3. The first step for having a successful TKG deployment is having the TKG OVAs imported into vCenter. There are two required. The first is a photon image that will be used for provisioning our clusters. This contains all the components for building Kubernetes clusters in addition to vSphere specific components for the container storage interface and the cloud controller manager. The second image is the HA proxy OVA. This is responsible as acting as a load balancer in front of the Kubernetes master nodes for having a scalable control plane and distributing requests upon multiple nodes for the Kubernetes API server. When running from a local machine, the only prerequisites are having Docker installed and the kubectl command line ready to go. Using the TKG CLI, initialize it, specifying the UI flag, and it will automatically open a browser, giving the option to choose to deploy to vSphere or Amazon Web Services. This demo, again, will be using vSphere 6.7 Update 3. Filling out the TKG UI adds all the environment variables into a configuration YAML file. Using this file or exporting environment variables into a command prompt using the TKG CLI is required for having a successful deployment. Utilizing vCenter credentials, we will pull all available information from vCenter to make this process simplified. Adding an SSH public key is required for accessing the deployed machines. The control plane setting allows a user to choose an instance type that will fit their desired deployment with varying sizes based on how many Kubernetes clusters that management cluster will be managing, or if they desire a single control plane deployment or using a production deployment with multiple control plane nodes. After filling out the remainder of the fields, click on Deploy Management Cluster. This process will create a local Kubernetes cluster on the local Docker daemon using a technology called KIND, or Kubernetes in Docker. This will deploy all the necessary components to this locally running cluster. After this cluster is instantiated, it will deploy a new management cluster to the vSphere environment, where it will once again deploy the cluster API components, including those controllers required for vSphere. Then it will perform a move, where the settings on the local cluster will be transferred to the management cluster now running in vSphere. This process will take several minutes to complete. After this process is completed, looking at the vSphere UI, the control plane and the single worker have been deployed because we specified the type of cluster as development. Now that the management cluster is ready, we can now deploy a workload cluster by specifying TKG create cluster and the accompanying flags for customizing that particular deployment. Going back into the vSphere UI, the first machine that is cloned is the HA proxy VM. That will function as the load balancer to accept incoming Kubernetes API server requests for this cluster. If at a later time we could scale the control plane nodes to 3 and have the HA proxy VM be ready to distribute the work. Next, the control plane VM is created and goes through its process. Later, the worker nodes are then cloned. After cloning, kubeadm, which is an open source tool for easily clustering Kubernetes, is used to join them all together. Doing a kubectl get nodes shows us that the cluster is ready to start accepting workloads. At the same time, the CSI driver for vSphere has been configured, and all that's needed to deploy stateful workloads is applying a storage class. At this point, we've created our first workload cluster. Scaling a cluster is just as easy. Using the TKG CLI, we can specify a new worker count, and using the declarative nature of the Kubernetes API, Cluster API will make sure that this particular cluster has 3 worker nodes. Scaling down results in the same process by automatically removing worker nodes and deleting them from the cluster gracefully. Using kubectl get nodes shows that the nodes that are a part of this cluster and their status of being ready to accept workloads. Using the TKG CLI with our kubectl config context set to the management cluster, the workload clusters can be deleted using a simple command line of tkg delete cluster and then specifying the cluster name. Lastly, if we want to get our environment back to a pristine state, there is the ability to completely remove the management cluster in a clean way. With the kubectl config context set still to the management cluster, performing a tkg delete region will kick off the process of spinning up another kind cluster on our local machine where the cluster API components, including vSphere, are installed into it and the existing state of the cluster is moved off. Then the local cluster will perform the deletion of the management cluster, and then the TKG CLI will delete the local kind cluster, removing it completely. Thanks for watching this demonstration of VMware Tanzu Kubernetes Grid. For more information, please check it out at tanzu.vmware.com/kubernetes-grid.